This video is going to cover the translations, one of our 4 different kinds of transformations. So first, the warm-up, identifying the types of transformations: translation, reflection, rotation, or dilation. On the previous video or notes that we had, we did this exact same thing. In fact, 3 of these are exactly the same pictures. So we take a look at the first one. We talked about how it's changed in sizes. So when it changes in size, it's automatically going to be a dilation. The second one, our orientation has changed. All we have done is we've taken it and we have flipped over this line. The flipping is a reflection. The next one, the orientation is the same. D and D prime are in the same place, A and A prime. So all we've done was slid this image, well, I should say pre-image, creating the image. Your sliding is translation. The last one, big thing here, is we have this point here, and you're noticing that we have this arrow saying we're moving it almost like a clock, and that's exactly what it is. When we rotate, we're rotating clockwise or counterclockwise around a center point. So this is going to be a rotation. Please pause if I'm going too fast and get caught up. All right, so your translation. This is going to be a rigid motion. We talked about that in the last notes, where rigid means the same size. This is going to be in which every point is moved the same distance. So wherever you move point A, whatever distance you move, point B has to move the exact same distance and in the same direction. So you can't move point A up and to the left and then move point B down and to the left. Even though you're going the same amount, it doesn't matter. They all have to go the exact same direction. And a figure slides up or down and left and right. It can also slide diagonally with a combination of, like I said earlier, up and to the left. That would be considered a diagonal move. Now your coordinate notation, your notations for all your transformations starts with parentheses x comma y, showing you these are your coordinates. The arrow says, hey guys, this is what's going to happen to it. So what's going to happen is you're going to take x, you're going to add or subtract a number, which will tell you what direction to move. We'll talk about that later. And then with y, same thing. You'll add, we have a and b because they're not always going to be the same number, okay? And right here it says the arrow, the notation shows how it means it's going to go to. This is what we're going to do with it, okay? So it's just showing you that arrow and the A prime. Now, let's talk about our first example here. Maria marches with the band at the start of halftime show. Her position is at +2, +4, okay? Then Mr. Gorton tells everyone to move 3 yards to the right on the field and 1 yard, it says yards, but 1 yard up the field. Now, this is a big thing here, your directions. Or we talked about up, down, left, right. Your right is going to affect, your left and right will affect the x coordinate because that's where your x-axis is, left and right. So whenever you're moving to the right, you're going towards the positive numbers. No matter where you are, you're going towards the positive numbers, so this is going to be a plus. So that 3 yards, this is going to take that x, and you're going to add 3 to every x coordinates. And then whenever you're looking at 1 yard up and down is your y-axis. Up goes towards the positive numbers. Think about a thermometer. As it goes up, the numbers get higher. As you go down, you can get into the negatives. So we're going to go up 1. So up is y, and it's going to be a +1. So when we look at the coordinate notation, I'm going to go ahead and write it in so we can use like what we saw above. You're going to start with that x comma y and the arrow. And now you put in, okay, what did we do with x? We took x and we added 3, comma. We took y and we added 1. So that's your coordinate notation. So we want to complete this table right here. So what we're going to do is, with each one of these, we're going to add the 3 to x, every x coordinate, and add 1 to the y coordinate. So starting off with Maria, we're going to take the x coordinate of 2, we're going to add 3, and we're going to get 5. Then the y told us to add 1, so we're going to add 1, and we're also going to get 5. And this is the new location of Maria. With Joe, same thing. We're going to add 3 to the x, giving us 6 for our new x, and we're going to add 1 to the y. New y coordinate will be 8. Now look at Legeia. We don't have our starting point. We have our ending point. All we have to do is go backwards. So instead of adding 3, adding 1, we're going to do the opposite and subtract. Let's rewind, reverse, go to the opposite. So here, instead of adding 3, we need to add 3 over here, the pre-image, but we don't know what it is, so now we're going to subtract 3 and wind up, oh, she started at 4 on the x. And then your y, we want to do the opposite, subtract 1. So her original starting point on the y coordinate will be 10. All right, let's get some stuff on the graph here. The other band director, Mr. Freeman, that directs the band, so the band member at 6-4 and 4-7. In order for the entire formation of the band to move the same translation, we want to write a general function for the band members to use. Guys, all this means is write that coordinate notation. That is going to be that x comma y. You'll hear it called coordinate notation. You'll hear it called a rule. They're both the exact same thing. We have x comma y arrow, okay? So we're going from here to here. We're going from 6-4 to 4-7. Before we start with the coordinate, or continue with the coordinate notation, let's go ahead and plot both of these points. So I can show you exactly how. You can do it with the numbers, find the difference between the numbers, or you can do it on the graph. Let's go ahead and plot 6,4. So remember, 6 positive on the x, 4 positive on the y. Here's your starting point. The ending point is going to be at 4-7. So we're going to go positive 4, and then we're going to go to positive 7. Make sure I got this lined up right. So this is where we end. We always want to start with the x first because it's just going to make it easier, okay? Sorry, I like my colors. So if you want to get colors, great idea, especially with some of these things we do in geometry. It really does help out differentiate and see different things, especially with this. So let's start x. So we need to go from my red point to my blue point, my pre-image to my image. So let's go left and right. We notice we're going to have to go left. So let's see how many we need to go left to line up right here. And we find ourselves going 1, 2. So we went 2 spots, but what direction? We went left. Left is towards the negatives, meaning this is going to be an x minus 2. Okay? So left 2 is an x minus 2. Now we need to stay there where we're at, and let's figure out how many we need to get to go up. So we're noticing we're going to go 1, 2, 3. So we went up 3. So up and down is your y. Up, we're going towards positives, so it's y plus 3. So then we come back over here to our coordinate notation. Always start with x. X coordinate always comes first. We had x minus 2, comma. What did we do to the y? We did y and we added 3. So there you go, figuring out what the coordinate notation is. Again, rewind if you need to. Please go back and listen to it again. Now we're going to, I'm going to kind of speed it up a little bit, so please pause and rewind. That way we can make this video as short as possible. We're now going to graph the figure and its image according to the function they give us, okay, our coordinate notation. We're going to label the vertices and we're going to shade the image so we can very distinctly see what's what. So let's go ahead and plot these points. I'm going to, it's going to be triangle ABC, just right here. I'm going to pause the video and plot them. Please pause the video on your own, plot them yourself. Label the points as you do, connect them, and it will become a triangle. Please do this on your own, and then resume the video to see if you have it correct. All right, so here is our triangle ABC. I didn't label C, whoops-a-daisy. Now we're going to go ahead and we're going to take this coordinate notation, this rule, and we're going to apply it to every point, every single point, just like we did in the table. Okay, so every x we're going to go ahead and subtract 5 from it. So here we can go minus 5. And remember, I'm showing you how to show your work, okay? So please make sure you're showing your work. Actually, what I'm going to do is pause that as an announcement. Write and make sense of it. We have more room to write in our adding and subtracting. So go ahead and pause it and write that down for me real quick. And then we're going to go ahead and go through. Every x, we're going to subtract 5. So here, we can subtract 5, subtract 5, subtract 5. And you can do this one point at a time. Subtract the 5, subtract the 2 from y, then move to the other one, or you can do all the x's. It's all entirely up to you as long as you're doing it correctly. So here, we need to remember that this is our pre-image. Our image is a prime, so we need to make sure we have that apostrophe there, or it's just the same point. We've got to have that. So here, 0 minus 5, we need to know our negatives, doing this in our head, becomes negative 5. When we come over here to B prime, negative 2 minus 5 more. Use the number line if you need to. You're at negative 2, you're going to move 5 more, subtract 5 more. We're going to wind up at negative 7. And at C prime, negative 4, we're going to subtract 5 more, going further into the negatives to create negative 9. Okay, so there's your x coordinates for A, B, and C prime. The y, we're going to go ahead and subtract 2 from each one. And I'm just going to do this one at a time. Subtract 2 here, 3 minus 2, it's going to give you 1. So there's your new A prime. Negative 1, we're going to subtract 2 more, going further into the negatives, wind up at negative 3. And then the last one, we have 4 minus 2. We should all be able to do that one in our head. We're going to wind up at 2. So these are our new coordinates of our image, and we're going to go ahead and go plot this. Pause it, plot it, shade it in, make sure you are labeling A prime, B prime, C prime. Please pause it now. This should be your end result. Now another way you can do this is knowing your left and right. I like doing it that way whenever they give me the rule. You can also say, okay, well, negative 5, minus 5, x minus 5 is 5 to the left. So you can actually physically go from the point and count 1, 2, 3, 4, 5, and then down 2, 1, 2. And then there's your new point. You can do it that way as well. All right, let's take a look at number 4. We are going to go backwards. They are going to give us a prime in which they took the pre-image and completed this rule, okay? And this is where we ended up. Kind of like what we just did with, I forgot the name, Ligeia on the last page. So let's go ahead and plot point A, or sorry, A prime, because we don't know what A is yet. A prime we have at negative 7, positive 2. So here's our A prime. So a couple things you can do, you can work backwards, like what I showed you on this page right here, where we did the opposite. You can do that by all means. Or just know we're going the opposite direction. You can actually physically move it. I'll go ahead and show you here. If we have A, I'm going to show you this way. We don't know what A is yet, but we're going to land at A prime, which is at negative 7, 2. So what we want to do is we want to figure out, when I went from negative 7, I need to get to the pre-image point. Well, to get to negative 7, here we added 2. So we need to do the opposite, and we need to subtract 2. So negative 7 minus, I'm sorry, we got to do the opposite. Sorry, guys. We got to add 2. We got to do the opposite here. Add 2. So negative 7, okay, so again, use the number line. We're going to add 2. That means go to the right, and we end up at negative 5. To get from the pre-image to the image of the y, we added 5, so now we have to do the opposite, and we need to subtract 5. So 2, again, number line if you need to, we're going to subtract that 5 and wind up at negative 3. So this is going to be our final answer, working backwards. All right, next, we're going to graph and shade the image of the right triangle and determine the coordinate notation that represents the translation. So we already have, right here, we already have the triangle. What I want you to do, again, I'm asking you to pause the video. Plot them yourself, please. Go ahead and plot J prime, K prime, and L prime. Pause it now, please. Different size or a point's off, you know something went wrong, okay? So let's take a look at what we can do here. In reality, if you plotted it correctly, you really only need to take a look at one of the points, the pre-image and image points, to figure out what's going on. So let's take a look at L and L prime and see what happened. So let's look, obviously, X comes first, so left and right first. To get in line with L prime, how many did we have to move? We had to go left 1, and we know left and right is X, left is towards the negatives, so we have X minus 1. Now, again, you can stay right there, and you should meet up right with the point. We're going to find on the y, we're going down. So we're going to go down 1, 2, 3, 4. And up and down is y. Down is towards the negatives, so minus 4. We have 3 more problems, and we are going to be using the, it says algebra review. It's going to be a little bit of geometry review as well, but we're going to go ahead and use this pre-image and image that we just looked at. We want to know what the equation of the line that includes segment L prime, K prime. You'll learn segment in that little bar later on. So let's go find L prime, K prime right here on the image. This guy right here, we want to find the slope. So to find this, here's our slope. We need to remember we got our equation as y equals mx plus b, m being the slope, b being the y-intercept. Okay, so we can go and label that to remind us. And so slope, we want our rise over run. Here's our slope. M stands for the slope. We want rise over run. Easiest way to do that. So we start at a point, and remember, your rise is not always going to be up, okay? Notice we're going down the hill, so we're going to have a negative slope. But let's take a look. Rise over run, so up and down. To get from L prime to K prime, we're going to notice 1, 2, 3, 4. So we went down 4, and then to get over our run, 1, 2, 3, in the positive direction of 3, okay? Again, that left and right, negative and positive, add, subtract, they all tie together. Now, B, your y-intercept. Find out where on the y-axis that this line hits, and it's right there at positive 1 on that y-axis. So now let's go ahead and fill this in. We have y equals slope, negative 4 over 3, and then plus b. Well, b is a positive, so we will have a plus 1. Next, we're going to look at area. What is the area of triangle JKL? How does it compare to the area of the prime, the image? So first thing we need to remember is area of a triangle is going to be base times height divided by 2. All right? So let's take a look at our first triangle, triangle JKL. So your base, come back up here, your base right here, horizontal, is going to be 1, 2, 3 units. Your height was that 4. 1, 2, 3, 1, 2, 3, 4. So we plug into our formula right here. B is 3, H was 4, all over 2, and this ends up being 6. So let's take a look at our prime image here. J prime, K prime, L prime. Your base, right here, 1, 2, 3. Your height, 1, 2, 3, 4. So you could probably already guess what's going to happen here. So we have that 3 times the 4, divided by 2, 6. Again, this deals with your rigid motion, okay? Meaning same shape, same size. These are going to stay congruent. So the answer technically to this question is they're the same. Perimeter. Now, we already know the same shape, same size. It's asking us JKL. We already know 2 of the lengths. Okay, we know that we've got 3 and we've got 4. Problem is we cannot, do not ever count that diagonal, please. Do not ever, ever, ever count that diagonal because you cannot do that. All right, so instead we have to go back to Pythagorean theorem before we can add the numbers together. Pythagorean theorem is a squared plus b squared equals c squared. Remembering that across from that 90-degree angle, that's your hypotenuse, c. So we know that one leg is 3, so we have 3 squared, plus the other leg is 4, 4 squared, all equal to c squared. 3 steps to Pythagorean theorem. Square the two numbers. Here we go. 9 plus 16. Then you're going to add or subtract, depending on what it tells you to do. Here we're going to add them together and get 25. Remember to bring c squared down. Last final step in Pythagorean theorem is always to square root, so we can get rid of the square next to that c. What you do to one side, you always do to the other. So your third side ends up being 5. So your perimeter, you add the 3 plus the 4 that we already knew, and then we're going to add that 5 that we just found, and we're going to wind up perimeter of 12. If you have any questions, you can always go and Google. You can get on YouTube, look up some other videos, or ask your teacher for help or stay for tutorials.